Hello class, this is Mr. Eggleston and this is lesson 6.5, Exponent Rules. This actually is very important, this unit or this lesson, all right? The idea of all the exponent rules that you're going to see, and some of them you've seen before in pre-algebra, are very important going forward from here. When you go into Algebra 2, and if some of you actually end up going into like pre-calculus and calculus, you're going to find out how important they are. They are very important. So we're going to learn about use exponent properties to simplify expressions. That's the first learning target right here. We are going to justify properties related to exponents. And we're going to determine if two expressions are equivalent using exponent properties. So here we go. Basically, well, before we do that, let's do this. Remember, if you have 3 to the second power, that literally means 3 times 3. Or 6 to the fourth power is 6 times 6 times 6 times 6. So the exponent is a shorthand way of writing down repeated multiplication. Okay? That's the main thing you have to remember. And you should remember that. So stuff with variables, x to the third literally means x times x times x. All right? So here we go. They tell you to read through each of the following equations without showing any work or doing any calculations. Decide if you think each equation is true or false. Okay. Then work the equations out to prove that you are correct. No calculator. Change your true-false answer if necessary. If the statement is false, correct it to make it true in the last column. You may check your final work with a calculator. So they want you to do this without a calculator until the end. So here we go. The first statement is 2 to the third times 2 squared. Does that equal 2 to the sixth power? All right. I know if it's true or false, so I'm not going to bother doing this, but write down what you think it is. True or false. All right. Then let's work it out. Well, we just saw that 2 to the third is 2 times 2 times 2, and that 2 to the second, that's this piece, is 2 to the third. 2 to the second is 2 times 2. Okay, and if we count this up, we have 1, 2, 3, 4, 5 2's multiplied together. So this equals 2 to the fifth. All right, not 6. So it's false, actually. And the correct statement is that 2 to the third times 2 squared equals 2 to the fifth power. All right, the next statement is 2 to the fifth. I'll write that in yellow. And 2 to the fourth, I'll write that over here in blue. Does that equal 2 to the ninth? And by the way, this was false up here because we didn't write that. It is false. All right? I know the answer, but let's see what it is. Well, 2 to the fifth is writing 2 times 2 times 2 times 2 times 2. Let's see, 1, 2, 3, 4, 5. This is 2 to the fifth times 2 to the fourth, which is in blue. So this is going to be 2 times 2 times 2 times 2. This is 2 to the fourth. All right? Now, adding these up, or counting up the number of 2's we have 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 9. So we have a total of 9 2's. So this is 2 to the ninth. All right? So this and it is. So this statement is true. Okay? So it's not false, so we don't have to write anything over there. What I'm writing here is working it out. I'm showing you if it's true or false. All right. The next thing they're saying is if you have 4 to the 5th power divided by 4 to the 2nd, do we get 4 to the 3rd? The way you show this is I'll write the 4 to the 5th in orange on top. 4 to the 5th literally means 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. All over 4 squared, and I'll write that in blue. That's 4 times 4. Now, we know, or at least I hope, well, you know, at least I hope you know, that 4 divided by 4 is 1. And that 4 divided by 4 is 1. And notice I was able to divide out 2 4s on the top with the 2 4s on the bottom, and that leaves us with just 4 times 4 times 4, which is indeed equal to 4 to the 3rd. So you see, this is a true statement. Okay? So now, let's look at, and again, I'm only writing down true and false after I work it out, all right? Because I know what the answer is. Like I know for a fact that this one is false. This works out to be false. Oh, wait. I'm sorry. It works out to be true. I know for a fact it's true. I didn't look at it correctly. But let me show you why. So 5 to the 4th is 5 times 5 times 5 times 5. 1, 2, 3, 4. And then 5 to the 6th is going to be 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5 times 5. And again, we can make the same argument. 5 divided by 5, cancel out to 1, divide out to 1. 5 divided by 5 divides to 1. 5 divided by 5 divides to 1. 5 divided by 5 divides to 1. And that leaves us with just a 1 on top, because all the 5s divided out doesn't mean that's a 0. It just means, remember, there's a little 1 multiplying this initially. Okay? And then we have the 2 5s on bottom. Okay? So, and 5 times 5, because these are the 2 that are left. Right there. So that does indeed equal 1 over 5 squared. Again, this was true. Now, star this one, the next one, because this is muy importante. This idea, this statement that 2 to the 0 equals 0. I can tell you unequivocally that is indefinitely false. But you know how many of you will say it's true? And you'll keep saying it's true even after going through geometry next year and then getting into Algebra 2 the following year? Many students will still say that this is a true statement, and it's not. How do we know? How can you tell if it's true or false? Well, you can tell by, sorry, I've got to think about this for a bit. You can tell by just doing a quick little statement here. We're going to say this. We're going to start with 2 to the 3rd divided by 2, all right? That's going to be 8 divided by 2, which is, how do I say this in the space provided? Okay, I guess one way of doing this is to start with 2 to the 5th, all right? 2 to the 5th equals, well, let me go smaller. 2 cubed equals 8. All right, so this is 8. Now 2 squared is 8 divided by 2, which is 4. So you notice we're dividing by 2 each time going down. So, and the exponent goes down by 1. So 2 squared is 4. 2 to the first is 2. Notice each time we're dividing this number by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. So 2 divided by 2 is 1, and that's 2 to the 0. So 2 to the 0 is 1. I can also show you by using a calculator. I'm going to use my this one. We're going to go 2. Oh, thank you. We're going 2 to the 0 power and hit enter. Notice the calculator says it's 1. So that's a true statement. So 2 to the 0 is not equal to 0. 2 to the 0 equals 1. All right? It equals 1. So make sure you understand that, because this is the one that kids screw up all the time. The other one is this one down here, too, the 3 to the negative 1 power. Now, is 4 to the 3rd to the 4th power equal to 4 to the 7th? I know for a fact it's false. All right? You may not, but I do. Because remember, what does this mean? This 4 on the outside says we're going to take this inside, which is 4 to the 3rd, and multiply it against itself 4 times. So I'm going to literally do that. So 4 to the 3rd to the 4th is 4 to the 3rd times 4 to the 3rd times 4 to the 3rd times 4 to the 3rd. I have, this is right here, 4 to the 3rd raised to the 4th power. Now, since we're multiplying, we're adding the exponent. So that's 4 to the 3 plus 3 plus 3, 1, 2, 3, 4, plus 3, which is 4 to the 12th power, which is definitely not equal to what they said, which was 4 to the 7th. So that is false, and I just showed you why. All right, because again, this 4 on the outside says we're multiplying 4 to the 3rd against itself 4 times, which I represented with this statement here. Okay, so that's false. So what you're going to say is that 4 to the 3rd raised to the 4th equals 4 to the 12th. All right? Okay, now, and I'm just going to erase this to make this look a little bit neater. There we go. Okay. Now, this idea of 3 to the negative 1, does it equal 1 over 3 to the first? And that is actually true. That's another complicated one that kids struggle with. How can we show this? Well, we know that 3 to the first is 3. I'm just going to kind of make this table that we had up here for the 2's right here to be with the 3's. And then we get, if we decrease the exponent by 1, get 3 to the 0. And we divide 3 by 3, we get 1. And if we keep going to the left, then we decrease the exponent by 1. That means we divide this 3 to the 0 by 3 to the first, which is 1 divided by 3, and that equals 1/3. So yes, 3 to the negative 1 equals 1 over 3 to the first. That's an important property. Okay? Negative exponents wants to move the base. I always talk about how the negative exponent's sad and depressed. It's negative. So you see this, you have this negative exponent, and it's sad and depressed. It's attending Bullard, let's say, and it really wants to switch schools and come to San Joaquin Memorial. So it's sad and depressed until it moves. And once it moves, now it's happy because it's at San Joaquin, and it's a positive 1. So notice, as we move the exponent, as we move the base, notice it moves downstairs. Because what you may have forgotten is that there's a little 1 underneath. That 3 to the negative 1 is really a fraction, 3 to the negative 1 over 1. So the 3 to the negative 1 moves downstairs. All right. So the next statement is 3/5 raised to the 4th power equal to 3 to the 4th, 5 to the 4th. Well, again, I know this rule. This rule is true, and I'll show you why. Because 3/5 to the 4th power literally is 3/5 times 3/5 times 3/5 times 3/5. We multiply 3/5, 1, 2, 3, 4 times. Now, multiplying fractions means we multiply all the tops together. So that becomes 3 times 3 times 3 times 3. And on bottom, we multiply all the bottoms together. 5 times 5 times 5 times 5, which is 3 to the 4th over 5 to the 4th. And so that is a true statement. Basically, when you have a fraction and you have a power, an exponent on the outside, that goes to the top and it attaches itself to the bottom. All right? So a fraction raised to an exponent, you just raise the top to that exponent and the bottom to that exponent. Okay? Now, 7 to the 2nd raised to the 3rd power, does that equal 7 to the 6th? Well, since I've been doing this forever, that's true. Why? Because if you think about this, I kind of already said it above. 7 squared to the 3rd power is literally 7 squared times 7 squared times 7 squared, which is 7 to the 2 plus 2 plus 2 power, which is 7 to the 6th power. Okay? So this also is an important concept. When you raise a power to a power, you multiply the exponents. So, and 6 is literally just 7 to the 2 times 3. All right? Finally, the last statement is also true. I'll show you why. When you have a product of two things multiplied inside parentheses where it's raised to an exponent, you will end up distributing the exponent to both pieces of the product, both factors of the product, okay? So in this case, the proof of this would be that 6 times 4 to the 3rd literally means 6 times 4 times 6 times 4 times 6 times 4. Notice I have 6 and 4 multiplied against itself 3 times. So putting together the 6's, this is my favorite number, 6 times 6 times 6, or 666. And we have 4 times 4 times 4. Each of those can be written with an exponent, so that's 6 to the 3rd times 4 to the 3rd. So it's a true statement. There you go. Now, coming to the end of this, because I want to go home. The generalization, any number, any base, a, to the 0 power is always going to be 1. That's a huge concept. When you multiply two powers together, a to the m, a to the nth, and the bases, this is key, the bases are the same, it can be simplified as by adding the exponents. So that would be a, the base does not change, m plus n. Okay? When you have a to the m divided by a to the nth, what you end up doing is subtracting the exponents. And again, the bases have to be the same. You can't have 2 to the 3rd times 3 to the 2nd and expect to write that as 6 to the 5th or something. The bases have got to be the same number, all right? Or the same thing. So that's another rule. When you raise a fraction to an exponent, you raise the top to that exponent, and you raise the bottom to that exponent. So the numerator gets raised to the power of m, and so does the denominator. When you raise a power to a power, this property right here, you multiply the exponent. So that's going to be a to the m times n power. And when you have the product of two things, an a times b raised to the m power, you distribute that exponent to each piece. Okay? And the last one, when the exponent's negative, the base is sad, it wants to move, and it's going to move downstairs. These are the properties of exponents that you're going to have to memorize and know it like the back of your hand, because it's very important. Very, very important. There's one, so let's count these up. There's 1, 2, 3, 4, 5, 6, 7 properties that you're just going to have to commit to memory by doing a bunch of examples. And we're going to be doing tons of problems, both in class as warm-ups and as homework. All right, it's so easy to make these worksheets. And I'm going to slowly crank up the difficulty levels so you can start to see how you simplify these, because this is so important in algebra. All right, here it is. Quick notes. Learning target number 1, simplify expressions. Basically, you're going to rewrite expressions with exponents by expanding, reordering, canceling, and simplifying terms. Exponent properties, see bottom of front page, which is this. These are the basic generalization, the rules that you need to memorize right here. Commit this to memory, okay? Cannot express that enough. And that's the end of the first part.